Alright, so this is Algebra 2, April 14th. I'm probably not going to have anyone on because it's 4 o'clock. I was supposed to have done this earlier, but I was working on something else. Alright, I'm going to get my laptop set up so I can make sure that this is clear. Alex Gutierrez. I think that's Oscar. Is that Oscar? Hey, Oscar. We are doing Algebra 2. I already uploaded the new Algebra 1 video to YouTube. Hey, Oscar. We are doing Algebra 2. I already uploaded. Okay, that looks pretty clear. Hey, Blake. I'm about to do an Algebra 2 video. You're welcome to watch, but your Algebra 1 video I did earlier, and it's already on YouTube. Alright, Algebra 2. We are going to be working on 3 things today, actually, and I'm going to assign 2 things. One's going to be IXL, one's going to be a worksheet that I upload to Teams. And the reason I'm going to go ahead and do these 3 different things is because, well, 2 of them go together. Number 1 and number 3 go together in your IXL. This number 2 right here is going to be a worksheet because I don't like the way IXL does the problems on this goal number 2. This first goal, factor the difference of squares. First of all, we're still doing factoring. This is actually going to be our last lesson on factoring. And it's going to be a long one because we do have 3 goals. These are special cases. So there's some different factoring patterns that you haven't seen yet. Goal number 1, the difference of squares. And goal number 3, perfect square trinomials. Those are Algebra 1 lessons. They'll be in Algebra 1 on your IXL, goal number 1 and goal number 3. And then goal number 2 is Algebra 2. First of all, let's look at difference of squares. For your difference of squares, you need to be able to recognize that factoring pattern because it has 2 terms. Okay, there's 2 terms in the problem. Each term's a perfect square. The problem is always going to be a subtraction problem. Now, the subtraction can either come in the middle like this, like normal, or it can be at the front. So your difference of 2 squares looks like this, a squared minus b squared, showing that each term is a perfect square and it's subtraction. Here, each term is a perfect square. The subtraction is in front. And you would just need to rewrite this and turn it around. Let's look first at example 1. On example 1, it says factor x squared minus 9. Now, before we factor these, let me get a piece of paper and just refresh your memory. I'm going to get this piece of paper and refresh your memory on multiplying some special cases with the FOIL method. So just watch this for a second. You don't have to write any of this down. Let's say you had two parentheses side by side, and one was x minus 8 and one was x plus 8. If you remember, whenever we multiply these using the FOIL method, you multiply your first terms together. So if we multiply x times x, we get x to the second. If you multiply your outside terms together, you get a positive 8x. If you multiply your inside terms, you get a negative 8x. And if you multiply the last terms together, negative 8 times positive 8, you get a negative 64. And then when you combine your like terms, these first two in the middle are opposites, exact opposites. 8x minus 8x, that equals 0. So you're just left with x squared in the front and minus 64. Now look at that problem. See, that is the difference of two squares. So whenever you multiply binomials that are the exact same except one's a minus and one's a plus, the inside and outside terms always cancel out, and you're always left with the difference of two perfect squares. So now we're going to be going backwards, and we're going to be given these two perfect squares, and we got to go backwards and write our answer in factored form. So that's what these examples are. This, like I said, this is super, super easy. These first few examples that go along with goal number 1. So, on this first one, x squared minus 9, you need to recognize that x squared is a perfect square, 9 is a perfect square, and we are subtracting. So that means it's automatically going to go into two parentheses. The binomials are going to look exactly the same, except one's going to have a plus and one's going to have a minus. And then you just take the square root of each term. So the square root of x to the second is x. The square root of 9 is 3. And then the other parentheses has x minus 3. So x plus 3 times x minus 3. It does not matter if you put your plus first or if you put your minus first. And that's all you do. That is your answer. So example 2, you have the difference of two perfect squares. The square root of 16z to the second is 4z, and the square root of 1 is 1. So you're going to have one parentheses that's 4z plus 1, and one parentheses that's 4z minus 1. And like I said, you can put the minus first. It doesn't matter which one comes first. Now look at this next one, example 3. Be careful with this one because 4d to the second is a perfect square, and so is 256. However, you've got to factor out a GCF first because there is a GCF. Anytime there is a GCF, you have to factor that out first. So be careful on IXL because if you're in a hurry, you're just going to factor this as 2d minus 16, 2d plus 16, and that's going to be wrong because you have to pull the perfect square, or I'm sorry, you have to pull the GCF out front. So the GCF between 4d squared and 256 is 4 because 4 goes into both of them. Factor your 4 out and divide, and inside your parentheses, you're going to be left with d to the second minus 256 divided by 4 is 64. And then once you have pulled your 4 out front, now inside the parentheses, you have a difference, because it's subtraction, of two perfect squares. So you have to factor this parentheses, just like we did in example 2 and 1. So you just write the 4 down in front, and then you take the square root of each one of these terms. That'll be d minus 8 and d plus 8. Alright, so again, this one has a GCF, so you have to pull the GCF out front, and then factor what's left in the parentheses. Take the square root of each term, you get d and 8, make 1d minus 8 and 1d plus 8. Again, it does not matter if you put your minus first or your plus first. Alright, example 4. We have 242 r to the second minus 50. Again, I notice they're even numbers, both of them, which means that they can be divided by 2 at least. So you've got to find, again, the GCF. And 2 is the GCF. So I'm going to pull a 2 out front and then divide 2 into each term. 2 can divide into 242 121 times. So you get 121 r to the second. And then 50 divided by 2 is 25. And you should recognize inside the parentheses you have the difference of 2 squares. So you're going to take the square root of each term. The square root of this first term is 11r. The square root of 25 is 5. So you're going to get 2 and then times 11r minus 5 and then do 11r plus 5. And that is your answer. Alright, so that is all there is to the very first goal, factor the difference of squares. Make sure you know what it's called, the difference of squares. Now we're going to move on to perfect square trinomials. Now this is goal number 3. Goal number 3 was factor perfect square trinomials. Perfect square trinomials have 3 terms. Y'all know trinomial means it has 3. So first thing you want to do is look and see how many terms it has. If there's 3 terms, then you want to check for your first term and your third term being perfect squares. The one in the middle doesn't matter yet. All you are worried about is the first term is a perfect square and the last term is a perfect square, the third term. Okay, this is how it looks. A squared plus 2ab plus b squared. In other words, using a real problem, it looks like this. X squared plus 6x plus 9. Because the first term is a perfect square and the last term is a perfect square. Now, this middle, you'll see where that comes into play, the 2ab. I'm going to show you where that comes into play when we're working out these examples. Okay, example 5. It says factor x squared plus 6x plus 9. Now, let me get my piece of paper and I want to show you. We've already done trinomials that weren't all perfect squares, and so if I had not told you anything about this problem, you would probably see that it's a trinomial and think, I need to make an x in each parentheses, and then what numbers can I multiply to get 9 that will add up to be 6? And it's plus 3 and plus 3. And that is the answer. However, we're going to write it like this, x plus 3 to the second power, because there's 2 of them. But I'm going to show you how to get this answer without putting the 2 parentheses down, because this is the way they're going to want you to enter it in IXL for this lesson. So on this one, you recognize that x squared is a perfect square and 9 is a perfect square, the first and the third terms. And so you're going to put 1 parentheses to the second power. Don't forget the little exponent of 2. And then you just take the square root of the first term and write it in the first term in the parentheses. Use the sign of the middle term. And then take the square root of this last number, which is 3. That's all you have to do. Now, where the 2ab comes into play and where this 6x comes in is you just need to multiply these 2 terms together. X times 3 is 3x. and then double it or multiply it by 2 always. This tells you to always multiply it by 2. And so 3 times x is 3x, and when you times that times 2, you get 6x. That's just a way to check to make sure that these are the right numbers. When you're factoring it, you don't have to do anything with that 6 when you're factoring it. You just take the square root of the first term, the square root of the last term, put it in one parentheses to the second power. All right, so let's look at example 6. Example 6, you see there's 3 terms. The first term is a perfect square. The last term is a perfect square, which tells me that most likely I'm going to be able to put it into a single parentheses to the second power. That's called a binomial square. And you take the square root of the first term. Square root of 25c to the second is 5c. Use the term or use the sign of the middle term, which is plus. And take the square root of 1. The square root of 1 is 1. And then all you have to do, make sure you've got the exponent on the outside. All you have to do is multiply those two together. 5c times 1 is 5c. And then double that and you get 10c. That's just a way to check it to make sure that you have the right numbers in here. All right, example 7. Remember, always check for GCF in any factoring you do. I don't think you're going to have any GCFs in these trinomials, though. All right, example 7. You have 49k to the second, which is a perfect square. Jump down to the end. You have a 9, which is a perfect square. So I'm going to put it into parentheses to the second power. Take the square root of 49k to the second, which is 7k. Use the sign that's in the middle, which is minus. Square root of 9 is 3. And that is your answer, 7k minus 3 raised to the second power. Remember, all you have to do with this 42 is just, when you get your answer, multiply these two terms together and double it to check, and you should get that number in the middle. 7k times negative 3 is negative 21k. When you double negative 21k, you get negative 42k. And then example 8, this is our last example for this one IXL assignment. So again, we have perfect square trinomial. I'm going to put my parentheses to the second power. Take the square root of 9n to the second, which is 3n. Take the square root of 64. Use the sign that's in the middle, so that'll be minus 8. And that's your answer. Just check it now to make sure that when you multiply these two in the middle, 3n times negative 8, you get negative 24. When you double that, you get negative 48. All right, so that's our goal number 1, which was difference of squares. Our goal number 3, which was perfect square trinomials. Your assignment, that goes back to Algebra 1. Make sure you click on the tab on the left side that says Algebra 1 and do AA6. Get a SMART score of 80. All right. I don't believe anyone is here live, so we are, I'm just going to move on to our next lesson. Remember, we're doing another lesson with these. This is your algebra, real Algebra 2 lesson. And this is the lesson that I'm going to give you a worksheet with because I don't like the way it's done on IXL. All right. Algebra 2, factor sums and differences of cubes. Cubes. So before we do anything, I need to go over with you what some perfect cubes are. Now remember, a cube is whenever you multiply something by itself 3 times. So like 1 times 1 times 1 is 1. 1 is our first perfect cube. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. 6 times 6 times 6 is 216. And 7 times 7 times 7 is 343. Now, I, of course, could go on with 8 to the third, 9 to the third, 10 to the third. But I don't believe you'll have too many of those on your worksheet that you'll need to know. Also, when you're working with variables, a variable term is a perfect cube if the exponent's divisible by 3. All right, so like x to the third, x to the sixth, any multiple of 3, not x to the ninth, x to the 12th, because exponents work differently than the regular numbers. Now, this factoring pattern is called the sum or difference of cubes. The last one that we did with two perfect squares, those had to be subtraction problems. But with two cubes, it can be addition or subtraction, sum or difference. And they're almost done the same way. You'll see one little thing that's different whenever we start working through our examples. Here's some characteristics of this pattern. Two terms. Both terms are perfect cubes. It can be a plus or a minus. And this is what it looks like. Here's an example of a problem. X to the third minus 1. Or x to the third plus 8. Now, let me tell y'all something. Now, if you were to see this, if you were to see x squared plus 8, you look at that and you say, well, x squared is not a perfect cube, so I'm not going to factor it like I would the perfect cubes. This is not a subtraction, and they're not perfect squares. The 8's not a perfect square. I factor that. I'm just showing you this to show that there are problems that don't have perfect squares and perfect cubes. I don't think you'll have any in your IXL. If you were to see x squared minus 4, you should recognize that that is the difference of two perfect squares. So you would factor that as x minus 2 times x plus 2. But if you were to see this problem, x to the third minus 8, those aren't perfect squares. Those are perfect cubes. And so you have to factor it the way I'm about to show you in these examples. All right. Example 1, factor r to the third plus 64. First thing you need to do is recognize, hey, there's two terms. So I'm going to look at my two terms and see if they're perfect squares or perfect cubes. They're perfect cubes because this is an exponent of 3 and 64 is a perfect cube. Okay, so the way that you factor this, it's going to look confusing to begin with, and then it's just a little process you have to memorize. You take the square root, not the square root, I'm sorry, the cube root of r to the third. That means what times itself 3 times is r to the third, and it's just r. R times r times r is r to the third. And then you keep this sign, plus, and you take the cube root of 64. Now the cube root of 64 is 4 because 4 times 4 times 4 is 64. So you get r plus 4 to begin with in this parentheses. In these kind of problems where you've got the sum or difference of cubes, you're always going to have a binomial times a trinomial. All right, so here's my trinomial. Once you have your r plus 4, then all you have to do is look at this binomial and work with it. You don't have to look at the problem anymore. You always square this first term, r times r, and you put it first in the trinomial. So that's going to be r to the second. You always multiply whatever's in the binomial together and change the sign. So r times 4 is 4r. And you change the sign to minus 4r. And then you always take the last term in the binomial and you square it. 4 times 4, which is 16. And it's always going to be a positive at the end. And that's your answer. R plus 4 times r squared minus 4r plus 16. Once again, going back over that, you take the cube root of r to the third, which means you just divide that exponent by 3 when you take the cube root, and that's r. You take the cube root of 64. which is 4, because 4 times 4 times 4 is 64. And I need to show you, I could show you on a calculator how to take the cube root if I had my calculator here. On your calculator, if you want to, hang on just a second. This is probably going to be important to some of you. Let me find my calculator. Okay, I'm going to zoom in to show you. Let's say you didn't know what the cube root of 64 was. On your, I can't see. Let's see. All right, on this calculator, on the square root key, if you hit shift, there's a cube root. Do you see that? It comes up with a little 3 index right here. That means cube root, and then you can just put your 64 in, hit equals, and it gives you, if I can shine it right, gives you 4. If you didn't know that. Now let me zoom back out. So, if you take the cube root of 64, you get 4. And then once you have r plus 4, all you do is look at that parentheses to get the rest of this answer. You're going to do r times r, which is r squared. You're going to multiply these two together and change your sign every time. That'll be a minus 4r. And then you always square the last, 4 times 4, which is 16. Alright, so now moving on to example 2. We're going to take the cube root of 8x to the third. When you take the cube root of 8, that is 2. Again, if you don't know that that's 2, use your calculator. And shift in the square root key gives you the cube root. Put 8 in, and then it gives you 2. Alright. So that's going to be 2x. You just divide the exponent by 3 because you're finding the cube root. And then use this sign, minus. Take the cube root of 27, which is 3, because 3 times 3 times 3 is 27. And that is going to be your first parentheses, your binomial. Now remember, once you have that, you put a trinomial behind it. And to get the trinomial that goes in here, you're going to take this first term and square it. 2x times 2x, which is 4x to the second. And then every time you're going to multiply these two terms together, 2x times 3, which is 6x, and change the sign. So that'll be plus 6x. And then take your last term, negative 3, and you square it, which means negative 3 times negative 3, and that's going to be a positive 9. That term at the end is always going to be plus, because when you square anything, it's always positive. And that's your answer. All right, moving on to example 3. Let me just look and make sure that everything's still clear for y'all. I might need to zoom out a little bit. I think this is good. Okay, up here, example 3. I hope when you look back at your video to see how to do this, that you have paper and pencil and that you're copying some notes. And if you are, I want to give you a little bit of time to see if you can do this one. So r to the third plus 125. See if you can factor that one on your own. And as you're working it, I'm going to work it too without talking, and then you can look to see if you got it right. Then I'll go back over it and explain it. All right, y'all can check. It looks like this got a little blurry. I don't know. Let me give it a second to see if it'll clear back up. I think that's good. All right, check your answer. You should have r plus 5 times r squared minus 5r plus 25. The way that you get that is you take the cube root of r to the third, which is r, the cube root of 125, which is 5, and then to get your trinomial, you square the first, r times r, and put the answer here, that's r squared. You multiply these two terms together and change the sign, so that's minus 5r. And then you square the last, 5 times 5, and that's 25. And then our last example, notice this one, you have negative 8 into the third plus 1. Well, there's a negative in front, and you can just leave the negative in front. I don't like for my negatives to be in front. So what I'm going to do is turn this whole problem around, and then you don't have to do this. Since you're not doing it on IXL, you're doing it on a worksheet. You know, I'm not picky about how you write your answer, so you can just leave it this way and take the cube root of a negative 8, which is negative 2. You just have to remember your negative sign. But I'm going to turn this around, and I'm going to start off with the problem 1 minus 8n to the third. And then factor it like the others. So the cube root of 1 is 1. And then minus, because that's minus. The cube root of 8n to the third is 2n. And then all you've got left is the trinomial that you get when you square the first term. 1 times 1 is 1. Multiply these two terms together in this binomial. 1 times 2n is 2n, and change the sign. So that'll be plus 2n. And then square the last. Negative 2n times negative 2n is a positive 4n to the second. It looks like it got blurry again. I'm going to see. I'm going to give it a chance to get straightened back out. Hang on, my phone's going off. It's the school. The school's calling. I wonder what they're going to say. I guess I'll find out later. Alright. That looks like it's still a little broken up, like you can't see it. Let me zoom in and see if it straightens itself out any. There. That cleared up. Again, what I did is I took this binomial and turned it around and made it 1 minus 8n to the third. Then I took the cube root of 1 and the cube root of 8n to the third and made it 1 minus 2n. And then in your next parentheses, you just square your 1. 1 times 1 is 1. Multiply these two terms together and change your sign. 1 times 2n is 2n, and you change it to plus. And then square the last. Negative 2n times negative 2n is positive 4n to the second. And now, I think it's good that we're about to get off here because my video feed keeps saying it was interrupted. If you can't see that, what I wrote down is your assignment. Your assignment is the worksheet. It says go to Teams and go click on your assignment. I don't have it on there yet. I will have it on there after this. Click on your assignment on Teams and then upload the file that's going to be with it. It's going to be a worksheet. The worksheet has 2 pages, but you only have to do the first page, the 1 through 10. Make sure that you get a piece of paper. You write all the problems and the answers to 1 through 10 on your sheet of paper. Then you need to take a picture of it. Once you've completed it, take a picture of all 10 problems and then email that picture to me to get your points. And at this point, I wrote down what you should have completed. You should have, well, plus today's lesson. You won't have that completed yet. You should have I1, AA4, I3, AA5. Today you got I6. No, I don't think you got I6 today. What did I give you today? Let me find my sheet. I'm going to have people confused. I'm sorry. Scratch I6. It should be AA6. And then the worksheet and the quiz. Remember, we had a quiz on Teams. Not all of you have done your quiz. That's important that you do it because it does count. Okay, so the new lessons today, you had 2 new lessons, AA6 for the special cases, and then the worksheet that's going to be on Teams. I think I might have messed up. No, I think this is right. All right, I'm gonna double check and make sure all these are right here because I'm switching back and forth. The A's are Algebra 1, the I's are Algebra 2. I believe that's right. If it's not right, I will send my wonderful Algebra 2 students an email to tell you, but I think that's right. Today's lesson, though, again, IXL AA6 and the worksheet that will be on Teams. All right, y'all have a good afternoon. Bye.